Hello, my name is Rob Soto, and I'm here today with Jose Hernandez to talk to you about Git Well Hunt, a tool to discover leaked credentials in GitHub. So let's get started. As I said before, my name is Rob Soto. I worked at Splunk as a principal security researcher. I worked with Jose Hernandez. Previously, I worked at Akamai, Prolexic, and also worked at Caspita, machine learning, AI, user behavior analytics. And recently, I co-founded Pacific Hackers and Pacific Hackers Association. I also previously co-founded Hack Miami. And like I said before, I'm here with Jose Hernandez. So I'm going to let Jose introduce himself.
And I'm Jose Hernandez, also threat research manager here at Splunk. I work alongside Rod for now quite a while. We actually helped fight DDoS for Fortune 100 companies when we started, I think, early on in our careers. Co-founded a company called Zenedge, which is now Oracle's web application firewall. Got acquired a few years back. I've worked in multiple organizations where I basically focus on eradicating evil, just like we do today with our team here at Splunk.
Okay, so let's talk a little bit. Where do we find this tool? Git Well Hunt. So like we said before, Git Well Hunt is a tool to discover leaked credentials in GitHub. You can clone it. Basically, as you can see in this slide, you can go to github.com/D1VIOUS/git-well-hunt. And there's a couple of requirements. One of them is virtual env runs on Python 3. And once you clone it, you can use pip tool to install the requirements. You're going to need the API token, API key from GitHub that's necessary for this operation. And from there, we can start using the tool. Here's a couple of things that you probably want to take a look at. One of them is the location of the GitHub token, especially under the git-while.hunt.conf file. The output results, obviously you want to know what's going on because it tends to be very verbose once you start operating. And once it starts operating, you want to make sure you can gather and store the results that you're getting from this tool. The log path, which is something that you may want to look at if you encounter some hiccups on how the tool is operating. The log level, of course, which is either info or error, and the regexes. The regexes obviously are pretty important because that's the base of what we're searching. And we're going to talk a little bit more about it in just a second. So here's some examples of the actual credentials that you can find using this tool. You can actually use the parameter -s and input a specific info if you're looking for other type of credentials, for example. But in this case, let's look at some basic examples. GCP tokens, for example, API secrets, Azure, GWT tokens. You can also find AWS API secrets or Azure tokens or GCP token files as well. So what is it that this tool checks for as far as the type of credentials? As you can see out of the box, because you can obviously, if you can manage to add regexes and obviously other type of credentials, you can add more than what you see here. And what you see here is basically around 38 type of credentials. And here we have, we start with the classic AWS API keys, which are very popular nowadays. But we also have things such as GCP Service Account Tokens, or Google API keys, or GCP Platform OAuth tokens, which usually is short-lived, but you might get lucky. You can also have things such as Google Drive API keys, or even things such as passwords and URLs, um, RSA private keys, even SSH keys, which of course it's something sort of delicate if we're talking about infrastructure nowadays, uh, and other things such as Square access tokens, or Twitter access tokens. So these are things that you can search with this tool. These are things that are out there right now. Jose is going to give you a demo where you're going to be able to see the gravity of this problem. Even though we've been showcasing this tool now for almost 2 years, we continue to see leakage of tools. So this tool is valid. This tool was rewritten recently because GitHub actually put some protections in place in order to basically rate limit the amount of queries that you could do. But we were able to rewrite this tool, Jose, who's the mastermind developer, and we were able to bypass this limitation. So the tool works perfectly fine, and you'll be able to get the results as expected. So to look a little bit of why are we trying to address this? Well, because it's a problem, and the problem comes, among other things, for sort of what you're looking at in this slide. We are now in environments that, due to the adoption of cloud environments, due to the adoption of streamlining operation workflows in information technology, for example, deploying infrastructure, or the publication of code, it's like there are too many pieces, as you can see in this graph. And all these pieces usually interact in workflows. In this case, what we're looking at is the now classic sort of infinite cycle of DevOps, right? Of continuous integration, continuous delivery, where you plan, build, deploy, operate, you get feedback, and then you go back again, and it's never ending. And when you apply this workflow with all these disparate technologies, you have to create what in some circles is called systems of trust. And the systems of trust, they need some sort of a token, to call it in a certain way, to allow passage of information and to allow trust of different systems. And when this happens, you have to choose, right? And what that ends up being, operationally speaking, will be some sort of a token, right? And the token will be defined by the standard, and the standard will tell us, the specific characteristics of it, and configurations of it, which is something that we had to look by token and by platform. But the bottom line is, in the process of the passage of these tokens in these systems, there are risks, and there are risks that, because of the interaction with, among other things, cloud repositories, for example, you may get leakage of these tokens credentials that end up in places that are accessible publicly, and that may allow attackers to access internal resources in your organization. And what we're seeing here is aggravated by what we call a converged perimeter. A converged perimeter is a new type of perimeter. Before, we were able to define clearly where the perimeter ended. You see your gateway, your firewall, your WAN, your gateway router, whatever was the definition of what was the border on your network. Now, when we have basically the um, converging of cloud infrastructure, perimeter infrastructure, then we get this gradient as you're seeing in this graph where we encounter a perimeter that is extended by the cloud infrastructure that you may not own, that you may be leasing, but for the purpose of usage and for the purpose of the attacker. If you have data that they want and this data is in the cloud, it doesn't make any difference for them. Same thing as a way of access. We're looking at nowadays campaigns where the initial access comes from resources that are facing the internet many times, either instances or credentials that are being reused that were found in public repositories. And the case that we're talking about is obviously GitHub. So here's some of the examples of some of the things that we have been seeing, right? We have, for example, developers, which usually have high privileges because of the type of operations that they need to do. And of course, when they leak a credential either by omission or neglect, that is at risk. So these are things that need to be monitored. Many times, because of the nature of the deployment of infrastructure or even code, what we call ephemeral environments are used. What's an ephemeral environment? An ephemeral environment is something that you build. We're nowadays into the infrastructure's code. We use Ansible or any other technologies available, Terraform, you name it. And we build these environments. We test our code, publish it, test it. It's all good. I destroy it. I don't need to keep servers out there. I don't need to keep containers out there. But many times, because of this, we tend to download, for example, containers from public repositories, or there's a lot of lack of monitoring of, for example, libraries and even applications that come many times embedded in these containers. If we were talking, for example, Kubernetes, for example, and that right there represents a risk. And this risk is not only, for example, vulnerable libraries or applications that are embedded in these containers, but in the case that we're trying to apply here, which is there is credential reuse, obviously, that increases exponentially the amount of access an attacker can have. This is obviously augmented by this connection between developer and security operations. Many times security operations has no idea that the development department is downloading all these tools, all these containers without any tools of checking, any processes in place. And like we said before, we're seeing this, and you're about to see in the demo of how credentials end up in public repositories. Also, we do have to face in a scenario where because of the use of the workflow that I previously showed, the continuous integration in delivery, the link to production is immediate. So any mistake, any over many things that may not be monitored or lack of tracking, these mistakes will replicate immediately and will show up in production environments many times exposed to the internet. Other things, obviously, there is obviously as there is lack of control, lack of monitoring. There is a risk of a rogue insider abusing this type of environments, and obviously disconnection between perimeter and cloud environments have made it worse. Whereas before, We just needed to account for assets. We just needed to account for what is inside or what is defined of our perimeter. That's no longer possible. In many instances, depending on the maturity level of an organization of adoption of cloud infrastructure, they don't even have visibility in it. We have seen cases where they don't even track creation of keys. They don't even track creation of users. They don't even track, for example, in AWS, creation of trust policies. These are things that need to be looked upon and that may be derived in many cases of post-exploitation artifacts from a malicious actor that has found initial access via leak credentials. So let's take a quick look at this. This is basically the primary source of leak credentials. We can go not only on GitHub. You know, there used to be a time where S3 was like the main place where you will find leak credentials, but we have other places such as Bitbucket, GitLabs, OpenDB, and of course we're talking today about GitHub. So these are places where you can certainly look for leak credentials, codes, application code that has embedded credentials. And clearly, what we're trying to prevent here is by looking at the Mitre cloud attack matrix, which is a Mitre is the nomenclature and the language in the industry is currently speaking. We're trying to basically look at T1078. T1078, which has also a number of subtechniques, is in regards of valid accounts. So basically, we're trying to prevent a malicious actor going into using a tool that allows him to discover keys. In some cases, like I said before, some companies don't even track root keys or even use root keys for specific processes. And if these root keys, for example, in AWS, get leaked and you don't have either access policies or any other sort of mitigating factors in your environment, you may be giving the keys to the kingdom to an attacker or somebody that basically coincidentally came across them, tested them, and then they worked. So you got to be careful with this type of scenarios, and that's why we created this tool. And with that, I'm going to pass it on to Jose, and he's going to give you a demo of the tool and the data that we were able to find now, almost 2 years after we started showcasing and using this tool and collecting information. So take it away, Jose.
Thank you, Rod, for that awesome background and also introduction on how to find credential leaks with GetWellHunt. Now I actually want to show you how this works. So with no time wasted, let's jump right into a demo. All right, so here we're starting off with me already cloning down the project, and we're in the master branch. And if I just do an ls here, you'll see these are all the same files. It comes down with the project, except one here which has my actual token in it. I'm not going to show it to y'all, but again, if you haven't created a GitHub token yet, there's some instructions in the project to create one. Please follow that first. You're going to need repo level privileges. We use these repo level privileges to actually search GitHub through the API. Now, quickly, before I run the tool, I want to show you the conf file. And again, all you need is to insert your token here. If you don't, I think the tool can still run, but you'll run into all kinds of interesting rate limits from GitHub. GitHub opens the rate limits once you provide a token for searching. And everything else just stay the same unless you want to output the results into some sort of other file name, or you want to log to another path. I wouldn't be messing with any of these. Now, next thing we need is we need to create a virtual environment. And first you need the virtual env tool, and I'm going to assume you have that installed. So we'll just run virtual env, and I'm going to pass it a parameter for P for the type of Python version I want. Specifically, this tool is meant to run on Python 3, so I want Python 3, and I'm going to create the virtual env under the folder venv. And the reason we do this, by the way, primarily is so the libraries and dependencies the tool uses and we install, they don't mesh and they don't get merged in with the systems one, right? So it creates our own Python environment that we can install dependencies into. So to activate the virtual environment, I'm going to go ahead and type in source bin, right into that VM folder, bin activate, and this activates my virtual environment. You can see here by the annotation of VM right on top, and now I should be ready to go. I should be able to run the tool. So I'm just, oh, never mind. I've missed a step here. If you don't install dependencies, even though you have a virtual environment, you're gonna get a like module not found kind of error. So in order to fix this and install dependencies, we'll run a pip install -r for requirements, and we're gonna pass it a requirements file. This is the file that has all of our dependencies in it. And it quickly runs through, installs everything, and we should be able to run the tool now. Boom, great. Okay, so tool's installed, we can run it, we have our token in place, now we can run our first search. Now, to run our first search, what I'm gonna do is I'm gonna reference really quickly the README, and I'm just going to go ahead and grab the AWS API example here, the secrets API example. And in order to do that, we'll just literally copy and paste the example that I've written there into the README, paste it here into our terminal, run it, and oh, never mind. I forgot to move the token over since our config file doesn't have the token right now. So let me move here my backup, which actually has my token, over to the conf file, and let's clear the screen and run it one more time. So went ahead and ran that command, and we can immediately see that there was 375 results found. And what that means was that if we search for anything in the path, any code with a folder on .aws, right? So this is the hidden folder for AWS with a file in it called credentials. There's about 375 of them committed right now in GitHub. Now what the tool is doing is slowly searching to see what are the available, given the available results, if there's any actual leaks in them. And this takes a few seconds, so we'll speed right through this. All right, so it finished processing all those results, and now it's trying to find potential leaks, right? And what it means by that is, again, it's not trying to match these regex across all the different results that we receive from GitHub. You can see, for example, here there was a potential match of what seemed to be an example API key, so this is a false positive. We keep going, this doesn't seem like a false positive. This might have been some actual credentials for this gentleman's Firebase, and yep, there's quite a few here. It goes through each result, right? And I've kind of let it run. Still going here. For example, this one is pretty crazy. This one found 4 results here. Mr. Kevin Dewey on a Dockerless serverless AWS commit. Right. Once it's done matching all of these, what it'll end up doing is it writes all these results into results.json, which is where what we've typically done right now is we've indexed that with Splunk. But excellent. Now that it's done, we can actually go here to results.json, and I'm gonna quickly just pipe this through JQ. Since it is a JSON output, JQ is a command line, a bash shell command line JSON selector viewer. I'll print basically the JSON for me and make it look better. So we can see here all the different results. And for example, as part of the result set, it grabs the actual URL of the credential leak, the match. In this case, since we are looking for the specific like AWS leaks, you can see this one match for an AWS account. This was the owner. It grabs a bunch of information specifically out of the GitHub profile for that user. So like the owner URL, the type of user it is, if they've registered a company or an email. Some users don't edit that in their profile, so we won't have that information, a location, a Twitter handle if they did add that in there. And then when was the owner or the user created. Now I'm just gonna grab here for the sake of example. I'm gonna grab here. I really like this one here. Bill W. Pierce. I worked for Amazon Secrets for a long time, so there's not much on here. And he put that in his bio, which is pretty interesting. He has a blog. I'm gonna go ahead and just grab that URL where the credentials, and I want to show you what that actually looks like. Right, like, this is the actual credential of this user. All right, so I opened up my browser here and I copied and pasted that URL, that leak URL from the gentleman Bill Pierce, and just gonna browse to it. You can actually see that there is the AWS secret key and the key ID in there. So again, this is in the log file. We of course don't store the secrets. We only store the matches, the key ID. But the secrets are indeed in there, and you can use the secret essentially to, if that account is still active and usable, come back and log in as whatever that user was. So Rod and I took that index file or that JSON file, and we've been essentially running this tool across all the different default searches we posted on GitHub for about 8 months now, almost to a year. And if we could have, we've been storing it on this index called GetWellHunt. And if you just go back, I'm just gonna go back 24 hours really quickly, and I want to show you. I just want to show you the power of this, right? Of collecting this data. Here again, you immediately see we get results for the last 24 hours, right, from the tool running. But if I go back way back, all time, you start seeing that we collected roughly about over 2 million credentials that have been leaked in the last 8 months. And with that, I want to conclude this demo, but I definitely want to jump into the data we've seen and some of the analytics we've been able to run with Splunk on this data. All right, so that was our demo. Let's jump into some of the data. I'm first going to start off here with something that I call the leak pie. And I mean, pie charts are not very telling from a data analytics perspective, but this one is a little bit fun for me at least to share and look at. This is I put the Splunk search here I used, and if you notice the Splunk search, I am deduplicating the data. So this is unique URLs, e.g. unique leaks that we saw across the board by the different checks, e.g. the different actual searches we've been running. And you can see that by far the most common thing we found were passwords and URL. But the odd thing was second to actual GCP service accounts being leaked. So passwords and URLs were the most leaked credential, second to GCP service accounts, and third to AWS API keys. But there's something really interesting in a second I want to show you about this relationship here. From there, I mean, we got some generic secrets, and you can see the regex for this. This is pretty generic regex, but YouTube OAuth tokens were pretty common as well. And I think this is kind of gets modeled in with also Google OAuth tokens. So a lot of YouTube OAuth gets used to come back to some media management, some other stuff. There's a few RSA private keys. Oopsie daisy, like that's not a good thing you want to see in there. And then, I mean, everything else is others in this case. Now, another interesting kind of factoid or pattern that we saw is that across the entire time we've been collecting this data, so we started collecting it back in July last year. They weren't. So we found we improved our tool early on. Like we were only checking a certain thing. So you see like that. That's why you see this whole huge jump back in December. But there was roughly about 25 unique companies at any given month that were really leaking things. And in a spike of this, there was most 42. And so what this told us, and again, these are unique companies. Doesn't mean that one company doesn't have a whole bunch of leaks. What this told us was there's a bunch of companies that just weren't checking for this, right? Like, not a whole lot, but just a handful, and they were pretty egregious. And again, these are when we say companies, these are users that actually put a company on the company profile in their GitHub. That's the only way we're able to know this. So there's potentially maybe a whole lot more companies or users that work for companies, but we just don't know because we don't have that information from GitHub. This is a pretty crazy graph here. And I know there's a lot going on, but I'll break it down really quickly. So first things first, I want to highlight here. With some math, we were able to calculate the average time a credential was out there and leaked before it was actually removed, right? Since we were running these checks hourly for the last 8 months, we were able to track the diff of when the credential just went offline or we didn't see it anymore. And we saw the average leak time was about 57 days. So that meant that 57 days, a credential was out there in GitHub before it was actually removed or cleaned up, right? And I mentioned about 42 companies, but some companies are, again, at least the ones that were tracked in GitHub, they kept coming back, or there was a lot of leaks for it. Well, I kind of broke down, and that's what this graph you're seeing over time, what company or the amount of companies that were leaking. And you can see by far, like, for example, Trend Micro, I did this highlight line charts on top of the stack bar. So you can see that, for example, Trend Micro had the most leaked at the peak, right, in some point in time, but it did track down, right? So a lot of these have cleaned up, which is amazing, right? But 1,300 leaked just in Trend Micro or companies or profiles that had tagged the company Trend Micro in their profile. VMware and eBay were like right there and then kind of following through. eBay actually just showed up at some point in October, November, and it again went down back in May, started falling off again, the radar, which is it's pretty sweet. Again, about the 57, this is a little bit longer than 57, but days, but it is a handful of like about 2 or 3 months you see a leak out there and then it gets cleaned up. Nostrum was pretty bad as well. And again, the VMware Nostrum, you can see this is a steady line that's been, essentially these leaks have been out there for quite a while and they haven't been cleaned up. But yeah, this is a pretty gnarly search. You can see, again, if you ever index this thing with Splunk or even Elasticsearch, you can use this similar logic in Elastic to build this chart yourself. And yeah, the final chart I want to show you here is what I would call the time chart of leaks. And the time chart of leaks, really what I was trying to find out is what was the relationship over time to different kind of token or credential types that were leaked. And again, I mentioned that we opened up the collection we were doing back in December. So you see this huge spike in December, and by far GCP service accounts were the most leaked type of credential in December, right? I think second to like generic and passwords and URLs. But then that got cleaned up heavily, and in January, boom, passwords and URLs just jumped right up, and it kind of stayed consistent, right? Like in April, there's a collection of like generic secrets, GCP service accounts, and password and URLs. But then all of a sudden, again in July, we've been seeing spikes of like AWS API keys being leaked, which is kind of odd, right? But you can see here how again over time, what's out there and what's getting leaked changes, and I'm assuming again this is based on either different programmers making different mistakes or projects going up and down, or maybe new products or demos that people build that they're testing and playing with, and they don't realize they're committing these credentials in there. Well, that concludes this Arsenal demo, but again, thank you for your time, and you can find the bits for Get Well Hunt on GitHub, and you can reach Rod or myself, Jose, over Twitter anytime. Have a good day.